Okay, so section number 5. Angle relationships. In circles. So there's 3 different kind of scenarios that we have, and there are some similarities to what we've been talking about, which is nice. But okay, so if we have a tangent and a chord, so let's call this A, B, and C. So I have an angle, over here, and I have like an angle over here. Now remember, the angle goes from the chord to the tangent line. We never measure an angle to a circle because a circle isn't straight. Okay, so in section 4 we talked about the angle is half the arc. But that was when like the angle was on the end of the circle like this one is. So the angle is half the arc. So angle 1 is half of arc AC. So it's similar, just a slightly different picture. So remember, if we use 2 letters, we're going to go the shortest way around. So from the A, you'd kind of go up to the right to C, like whatever. I guess I can use like another color. So we're talking about A to C. So angle 1 is half of whatever degree measure that is. Okay. Angle 2 would be half of arc ABC. And so remember, when we put that 3rd letter in, it's telling us we have to follow that order. Okay, so it can go like both like directions. So you could see a problem where it asks you for the red arc, but it gives you the blue arc or something, and you need to remember that 360 is all the way around a circle, or something like that. So, or maybe it gives you angle 1 and it asks you for the blue arc. Then you could say, okay, well, the red arc is times 2, and then you can do the 360 thing. So, but this is Theorem 1014. All right, Theorem 1015. So we have the angle on the end of the circle, or on the edge rather. We talked about that, like an inscribed angle yesterday, and then this one. So now we have like, well, what if we have some angles that aren't on the end, and they're not in the center? Remember, the center would be a central angle, and that equals the arc. But now we don't have them on the end or the center. So if I had angle 1, okay, so the angle is half the arc. So here's kind of a theme. Remember, I said that's going to be a big like kind of concept. So angle 1 is half the arc AD plus the arc BC. So it's still half the arc, it's just half of like 2 arcs. So basically what we're looking at is, I think it might say intercepted arc and the opposite arc. So it's, the arc that goes with the angle 1, and then if you do like kind of like a vertical angle, and then you go back over to that one. So whatever those 2 are, add them up, and then do half of that or divide by 2. Okay. If I had angle 2, then it would be the other ones. So it would be half DC plus AB. Kind of like a vertical thing there. So again, you're going to have the 360 all the way around is 360. I'm sure that's going to come up at some point. You know, the examples they give in the book are really basic. It would be something, and the numbers might not like work out right, but you know, it makes sense. But if that's 130 and that's 156, then you're just going to add those together. And then you'll do half. Or divide by 2, and you'd get 143. So they're fairly straightforward. Okay, so angle's half the arc added together. So when we have two chords or two segments that intersect on the inside of the circle, you're going to do half of the angles added together. Lines cross on the inside, it's half of the two arcs added together. All right. So this one, 1016, is like, well, what if they intersect on the outside? And we have 3 different scenarios of what can happen with stuff that crosses on the outside. What you do is still the same. So it's not like the formula or anything like that's going to change. Okay, so we have this one, angle A, so this angle way over here on the edge is half. And then we're going to look at the two arcs that kind of are between those two secant lines that are intersecting at A. So it's BE minus, so there's a difference, CD. So when the lines cross on the inside, you add the arcs together and do half. When they intersect on the outside, you subtract the arcs and then do half. And I should have written it the other way. The farthest one you should write first because that's going to be the biggest number. That way you don't get a negative angle. All right, so the other situation is, what if I have a secant and a tangent? Okay, so the two arcs with angle A would then be from B to D. And then I'm going to have to use a separate color because it's two separate arcs, but D to C. So angle A is half CD minus BD. Okay, so two secants, a secant and a tangent, and then there's only one left, two tangents. Oops, that's not very good. So this one is, it's still the same thing. Like here's our arc from B to C this way. and then from B to C this way. And so typically they'll put another letter out there because we would say angle A is half of BDC. We have to have that third letter to tell us to go the long way around, minus BC. So it's still, let me kind of write over this one, blue. It's still the same like concept. The angle on the outside is half the two arcs subtracted. Okay, so they intersect on the outside. The angle is half of the two arcs subtracted. Okay, so the bottom one, where there's two tangent lines, you'll notice it incorporates the whole circle. So I really only need to know one of the arcs for a problem like that. Okay, so if from like B to C this way is 120 degrees, you know, I'm trying to figure out the angle. Well, because it incorporates the whole rest of the circle, I can do 360 minus 120 is 240 degrees. So that's this other arc. And then I can do angle A equals half 240 minus 120, which actually is 120 or 60 degrees. Okay, so it's just identifying the two angles that, or excuse me, the two arcs that you need to use to either add or subtract together. Okay, and then there's one last one I forgot about. So Theorem 1017, so you know we still have a couple sections to go and we're already up to 17. So if we have like this picture, two tangents, and if they're tangent, I can draw a radius to make, excuse me, 90 degrees. Let me put this one on the other side. Okay, so you're going to see this word circumscribed. So it comes from circumference. Circumference means scribed means written. We had inscribed inside the angle. Circumscribed is, or inside the circle, is outside the circle. The circumference means around the outside, so that's where that prefix like circum comes from, and then scribed is just drawn. So this is technically like the circumscribed angle theorem is like the title, but again, I won't ever ask you for the title. I just want you to know the information. So basically, this is kind of an you could kind of figure this out if you remembered. So like four angles. So if you look at this picture that I'm going to kind of bold, it has four sides, or it has four angles, same thing. And so all the angles would add up to 360 degrees. That's just something that we've talked about before. So what this theorem is saying is, it says the central angle, and how do they term it? The angle that intercepts. So it's talking about this angle way out here. The central angle and the intercepted angle. So the central angle would be like angle B, and the intercepted angle is angle A. So the angle A and angle B add up to 180 degrees. And that's why I said this theorem you can actually figure out relatively simple without the theorem by knowing this. Well, if all of them add up to 360 and I have a 90 degree and a 90 degree, well, then that's just 360 minus 180 is 180, which is what the theorem says. So that one, I think, is one that down the road, I think I cut out, because you can figure that out without the theorem, and it's not like a ton of extra work. You just need to remember that, like I remember I said way back, all three angles in a triangle equal 180, four angles make 360. I said those two you kind of just need to know. It's an extra 180 every time you add a side, but I think knowing the 180 and the 360 is more important than like kind of going, well, 5 sides is 540 and 6 sides is 720. Like, you don't need to know all this. Okay. So essentially, if it tells you either angle A or angle B, you can just do minus 180 and you're done. Okay, which you will see at least once. All right. Okay, so a lot of, again, we're up to 17 theorems. That's a lot. But you got to keep going over them each day. So kind of go back over, even if you just read the book, all the theorems are in these like blue kind of outlined like boxes, and there's the pictures that I've been drawing for the notes, but to go back over and like just study those a little bit at a time. Okay? All right. That's all I got for you. Have a good day, guys. See you tomorrow.